We're looking at the law of sines today. So this 9.3 is the title of this section is the law of sines. So we're actually going to look at the law of sines today. Basically, we can use the law of sines to solve a triangle. You guys remember what it means to solve a triangle? Yeah, we want to find every side and every angle. So we can use the law of sines to find every side and every angle. But we do need some information from our triangle that's given to us. So we need at least some angles and some sides. So we'll need to have either angle, angle, side. So two angles and one side. Or angle, side, angle. Or we'll need side, side, angle. And hopefully you guys remember what these stand for. A's are angles, S's are sides, and it's in that order. So if it's angle, angle, side, let's see.
I know it doesn't make sense. Angle side.
So if it's angle, angle, side, it can be angle A, angle B, side A. So it'll be consecutive in that order. Or if I'm doing angle, side, angle, we can have angle B, side A, and angle C. Does that make sense? So angle, side, angle. And then if we're doing side, side, angle, we could do lowercase b, lowercase c, uppercase b. So it's not super important that you remember which ones we're using and which order of sides and angle we're given. What is important is that we have at least one side and at least one angle. Notice that none of these are angle, 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 and none of these are side, side, side. So if we're given just the angles, then that doesn't work. If we're given just the side lengths, then we cannot use the law of sines.
What about side angle side?
Side angle side would probably work too.
What about angle side side?
Hilarious. So we can use these guys here, and our equation's going to look like this. We have sine of angle A over A is equal to sine of angle B over B equals sine of angle C over C. Cool. And if you guys remember from yesterday, our angle measure lets us know where our side lengths are going to be. If my angle measure is A, the opposite side is going to be lowercase a. Makes sense, right? And if my angle measure is B, the opposite side will be lowercase b. If I have angle C, then the opposite side is lowercase c. So we can use this law of sines to figure out what missing pieces we have. This is not saying that all of our angles and all of our side lengths are equal to each other. It's saying that the ratio between the side lengths and the angles are what's equal. So not all the side lengths are going to be the same number. Cool? Cool. So let's look at an example. Do we have those three acronyms down? Yeah. So look at example 3. It says solve triangle ABC. We're going to round our decimals to the nearest 10th place, so that's 1 decimal point. First, we want to start off with the easy stuff. We want to get all the angles out of the way. So yeah, notice that we have two angles here, and we know that triangles add up to make
180.
180. So we can do 180 minus 107 minus 25, which gives us 48. So that means that angle A here is 48 degrees. And again, we know that because this total should be 180. Not bad? Cool. So using this information, let's set up our law of sines. We're going to start with angle A. So we're going to have sine of A, or sine of 48 degrees, over little a. Do I know what little a is?
No.
No, it's just a variable, so we're going to keep it as a variable. And that's going to be equal to sine of B, or sine of 25. And that's going to be over 15. We know that B is 15 because the opposite side from our angle B is 15. And that's going to be equal to sine of C, or
107.
107. Do I know what little c is?
No.
No, so I just keep it as a variable. Cool. Okay, so using this information now, we can solve for A and we can solve for C. If you guys remember from last Friday, we did some cross multiplying. So we can use cross multiplication to solve this, which is fairly easy. A lot of this is just calculator work, so most of what we're doing here is just setup. So if you notice, when I go through this, we're not actually doing a whole lot of math. So I'll show you what I mean. If I cross multiply, if I take sine 48 and 15, we can't really multiply these together because we don't know what sine 48 is, right? So we can just write it next to each other. Say we have sine 48 times 15. And we're going to set that equal to the other numerator and denominator. So we set this equal to a times sine 25. Or we can just say that it's a sine 25. Does that make sense? So from here, how do I get my a value by itself?
Divide both sides by sine 25.
Yeah, divide both sides by sine 25. So if I divide this by sine 25 and divide this by sine 25, then here these are going to cancel out and we can use our calculator for the rest. So as you can see, we really haven't done much math, it's mostly just moving the equation around. Questions on this so far? Not bad, right? Cool. So, if I type this into my calculator, we're doing sine 48 times, what was it? 15. And that's all over sine 25. Make sure your calculator is in degrees, and we get 26.4. So A here is now equal to 26. And we can do the same thing to solve for C. Does that make sense? So I'm going to take these values over here, cross multiply these guys, and cross multiply these guys. Yeah.
You can't do Pythagorean.
This is not a right triangle. Pythagorean theorem only works with the right triangles. Good question. Cool. So see if you guys can solve through this one on your own. Go ahead and try to figure out what C is using the same setup here. I'll give you guys a minute and then we'll go through it together. think we've got this, yeah? It's not too bad. So if I cross multiply here, if I do sine 25 times c, we can get sine 25 and c equal to 15 sine 107. If I want to solve for c, what do I need to do?
Divide by 25.
Yeah, divide sine 25 on both sides. This cancels out, and c is then equal to, yeah, 33.9.
Yay.
Not bad, right? Does that make sense? So cross multiplication, I think, is fairly easy for us.
Now we do B on your own.
So I actually want to change b because I want to show you guys something.
No.
So I'm gonna change b to something else. So just bear with me for now.
Are you gonna change B to summary?
No.
Oh, got it.
Can I scroll down from here? Are you guys all good?
Yeah.
Okay. So let's change b to a different triangle, or I'm just gonna change the values here. Let's get rid of that. Let's get rid of that. Get rid of that. That and that. And I'm gonna say that a is 40 degrees. Say that this is 13. This is 16.
Oh, that's a 13. I thought that was a B.
Sorry. Let me rewrite that.
It's literally right. No,
It's okay. It looks like a B. There we go.
Sorry, I'm blind.
It's okay. So switching this up a little bit, just because I want to show you guys what happens when we're given only one angle here. So here we're only given one angle, so we can't use 180 minus the inside angles to figure out what that last angle is, right? But we can still set up our law of sines. So if I'm going to set up my law of sines, what is it going to look like? Sine 40 over a, which is 13, equals sine b, 16, equals sine c over c. So notice with this one I have a lot less information in terms of what I can cross multiply, yes? The one I do have all the information of is angle A and side A. So I can use that to solve for sine of B. Does that make sense? So let's do that. If I solve this, we're going to do sine 40 times 16. Or we can say sine 40 and 16 equals 13 times sine of b. And how do I solve for sine of b? Divide by 13. Does that make sense? We come across an interesting situation though. If we do this, let's do sine 40 16 over 13. Sine 40 16 over 14. And we get a really small number, right? 13? Sorry. We get 0.791123, so on and so forth. But what happens here is, what we ended up getting, what was it, 0. What did I say? 7911.
Oh my god.
Gives us the sine of b, but does that give me the angle measure of b?
No.
No, so we need to solve for b. The way we can do that
Divide by
Cross
sine.
multiply.
is we use sine -1. This is our inverse sine.
Wait, so you don't have to cross multiply?
We already did. Yeah. So here on Desmos, if you look under a function, they have this sign with the -1 on it. So if we use that, sign -1, and then we can type in our answer from the previous section. Then it gives us,
What did you type to do that?
sorry,
Oh
sorry.
Do that. No, it's fine.
So we have sign -1, that's from our function, right? And then I can write A, N, S, and it takes the answer from the previous.
What?
5-minute crafts. 5-minute crafts.
If I got that,
Take out your cement mixer and.
The heck? Clip that.
A and S?
I don't know why I thought it.
That's going to the highlights.
Those of you watching can eat the back.
Montage.
What does A and S stand for?
Funny moments montage.
Oh my gosh. Life hacks, life hacks. I've been kept in the dark for too long.
So this gives us 52.3, yes?
Okay. Oh my god.
So initially, when we cross multiplied and we put this in our calculator, we got sine of b is equal to this, but that didn't give us the actual angle measure of b. So to get rid of sine, we did the inverse sine on both sides. So once that happens, it cancels out the signs, and then we're left with b equals 52.3. Now we can solve for that missing side c, and that's missing c is going to be what?
Oh, 180 minus something.
And that gives us $87.7.
87.
87.
Okay.
Yeah. 87.
So now that we have sine c, we can replace this one, right? With 87.7. And now solving for little c should be pretty easy. So go ahead and solve for little c on our own now. Yes.
Okay.
Whoops.
There's something wrong.
Plug in sine b as well. Sorry.
I was like, what am I doing wrong?
Yeah, that's also being replaced with 52.3.
Well, hold on.
Wait,
Sorry.
Yeah. Okay.
That goes there. That way we can solve it.
Okay.
Sorry. My bad.
oh.
Yeah. Sorry.
All towards each other. Yes.
I actually don't remember the answer off the top of my head.
Mercy.
So I'm assuming
How'd you get 87.7 again?
subtract 180 minus 40
Oh,
minus
okay.
52. How much time do we have? We need to hurry. Okay. We're good?
Yeah.
Okay, let's go through this.
Yeah.
Okay. Cross multiply, we get sine of 52.3c. We're doing these guys here. And on the other side, we have sine 87.7, and 16. If I divide both sides by sine of 52.3, then we get C is equal to 20.2.
Yay.
Not bad? Okay, I want to cover one last thing.
Oh my god.
Yes. Sorry, I know today is a little bit long, but. Okay. For the sake of time, I will come back to this if you guys need a copy of the rest of it. But let me move on for now, and then I'll go back if you need it. So, last thing I want to cover is possible triangles. There are times where we're given side lengths and angles that don't create an actual triangle. And if we don't create an actual triangle, then there's no math to be done on it, right? There's no way to solve it if there's no triangle given.
Why do we give ourselves more work though?
So just introducing this, I'm pretty sure you guys can guess what the next two answers are going to be. It's probably going to be no triangle, but I want to show you why. So here, let's say that we have an obtuse angle for A. So our A value is greater than 90 degrees. If our A value is greater than 90 degrees, or if our capital A value is greater than 90 degrees, then if our small a value is less than or equal to our b value, we have no triangle. And what that means is when our angle A is obtuse, if this side of my triangle is not longer than this side, then it won't connect all the way across. Makes sense, right? So we can't have a triangle if A is less than B, or even if it's equal to. It's not long enough.
Oh goody.
So when we have no triangle, then we can't really solve it, so we're done.
Yay.
So that's nice.
So is this the easy part of it?
Mr. Stone, I did this at Chino Hills and it took forever.
It's not that bad.
Some problems.
So some of them are. So, if a value is acute, if our a value is acute, then we have to compare that to our height. Here, if our a value is not longer than our height, then it's not going to connect on the other side. So here, if h is greater than a, then we have no triangle. If h is equal to a, then we have a right triangle. Because if our height and our a value is the same measure, then our height is our a value, and that creates a right triangle. Does that make sense? Does these pictures make sense?
Can
So using this information, we want to figure out, can we actually solve this triangle given the information that's given to us? Obviously, because I'm just introducing this, I think we can deduce that our answer is going to be no for both of these, but I do want to show you why that's the case. So take a look at example 4. Do I have an acute triangle or an obtuse triangle? A value is 51 degrees, so that's going to be acute. So if I kind of draw this out, we can say that angle A is 51 degrees. It doesn't have to be perfect, but I just want to kind of get an idea of what it's going to look like. We can put our C value up top, we could put our B value on this side over here. And we know that our B value is 5. So since our B value is 5, that's going to be opposite of our B value here. And we have our A value, but I don't want to put it just yet because I want to make sure that it's long enough. So since we have an acute triangle, we want to figure out what our height is here. So we have to compare it to our height. Is our height given to us? No. Can I figure out what my height is?
Oh, Pythagorean theorem.
Does that look familiar? We have our height, which is our opposite side. We have our hypotenuse, which is 5.
No. This again?
So we can solve for our missing side. So,
Oh my god.
Are you from the government? Is that why you're making us do this?
sorry. Opposite hypotenuse is going to be sine. So we can do sine of 51 equals height over 5. All we're really doing is multiplying both sides by 5 and using a calculator. So
That's still bad.
it's not that bad. So if we plug this into our calculator, multiply 5 times sine of 51, what's our height come out to? 3.2.
Wait, 5 times sine.
I got
Mhm.
3.9.
3.9.
3.9.
Just kidding. Yes, 3.9. So our height here is going to be equal to 3.9. Again, we're multiplying both sides by 5 to isolate the height. Now we can compare. Is h greater than a?
Yeah.
Yes. If h is greater than a, then I have
Acute.
Let's
no
go.
triangle.
Wait, what? I don't get that.
And if I have no triangle, I cannot solve this.
Yay.
Thank God we can't solve
Dude, don't show me this next one, there's 2 triangles.
I'm not going to get into that.
Sorry.
I cut out quite a bit. Alright, very last one. This one is very, very easy. Is my triangle acute or obtuse? Obtuse. Nice thing about obtuse triangles is I only need to compare A and B. So I don't need to draw anything out. Is A less than B? Yes. So do I have a triangle? No.
Oh.
So A is less than B is no triangle. 17 is less than 25. So we have no triangle.
Yay.
You said this was hard.
Sorry.
Yay for laziness.
Makes sense, right? Hopefully I didn't do that too fast.
No.
So why this was hard?
Because it's above 90 degrees.
James.
Cool?
Wait, so why? Oh, because, oh, never mind.
Alright. You guys can write your summaries. You guys can work on today's assignment.
Those of you watching at home, please don't forget to like and subscribe and hit the bell notification.
Sell out. Sell out.
Thank you.
Sell out.